Hello mates, in the previous couple of videos we're doing the vertical system. Now we're going to move to the first equatorial system. This system, at least now we have the basics of how to define celestial coordinates. So I do not think it will take us much time, but let's just see. I'll explain it best, and hopefully it will not take as much time as the vertical system. So the first equatorial system, as the name suggests, just like the vertical system, we are using the vertical as our starting point. We needed to put a plumb line in the vertical system. We needed to put a plumb line. From the plumb line, we're going to get the axis that linked our zenith and our nadir, and then perpendicular to that was our horizon, and then our horizon became our x-axis. In this system, we are going to use the celestial equator. This is what is going to happen. In the equatorial system, we first start with the celestial axis. So you know the celestial axis is like this. Imagine this is the Earth, and this is going to be our north geographical pole, and this one is going to be our south geographical pole. Now, there's going to be an axis, the terrestrial axis, that links those 2 points, the north geographical pole and the south geographical pole. But if we extend them out to our celestial sphere, if we extend this line out to our celestial sphere like this, it's going to cut the celestial sphere at 2 points, this point and this point. And this point will be the north celestial pole, and this one will be the south celestial pole. Those 2 points, they are connected by something called now the celestial axis. So the celestial axis is basically an extension of the terrestrial axis. We are just extending out the terrestrial axis all the way to the celestial sphere, to our imaginary celestial sphere. So that's where we start. This celestial axis is fixed because it's an extension of a fixed axis, the terrestrial axis. So it's fixed, so it's a good starting point. So let's start there. After we start there, the celestial sphere, can you see that the Earth rotates about the terrestrial axis? It rotates about the terrestrial axis, right? So as it is rotating from west to east, it's going to rotate from west to east, isn't it? That's what we know. It rotates from west to east like this, the Earth, about this axis. But due to what I termed the layman's third law of motion of Newton, as the Earth is rotating from west to east like this, the celestial sphere appears to be rotating like this from east to west, because of what? Of Newton's layman's Newton. I'm just applying Newton, but it doesn't really apply. I'm just trying to explain that for every action there's an equal and opposite reaction. The Earth, as it is rotating like this, the celestial sphere appears to be rotating like this in the other direction, from east to west. So now that is a point that we are going to use, and it appears to be rotating about the celestial axis. This Earth rotates about the terrestrial axis. The celestial sphere appears to be rotating about the celestial axis. So a plane through the observer. Now a plane through the observer to the celestial axis cuts the celestial sphere in a great circle called the celestial equator. So it's going to cut this in a great circle called the celestial equator, and cuts the horizon in 2 points. Okay, now let's do this. Let's leave this diagram and draw a new diagram that will make it easier for us. In the new diagram, we are going to draw the celestial sphere, and we are going to let our Earth be just a small point. So here is going to be our what? Okay, I'm going to tilt it a bit like this. This is going to be our north celestial pole, because I want to draw the person's zenith on top like that, and the person's nadir like that. So this is going to be our north celestial pole, and definitely down here is going to be our south celestial pole. So when we link the two, we are going to come up with what? With what we came up with, the celestial axis. And perpendicular, the plane that is perpendicular to this celestial axis gives what is called the what? The celestial equator. And it goes right at the back of the celestial axis, and then back in the front like this. So this thing is called the what? The celestial equator. This is going to be our celestial equator. which is in a plane that is perpendicular to the celestial axis, isn't it? The plane perpendicular to the celestial axis. Let me label, this is going to be our celestial axis. Celestial axis, like that. So now, due to the presence of this zenith and the nadir, the person has a horizon. So this is going to be the person's horizon. The person's horizon is going to be like this, because it has to be perpendicular to the one, to the axis connecting the zenith and the nadir. So let me remove this. These dotted lines, I mean the circle is going right behind. It's going behind this celestial sphere. So now, the zenith and nadir axis is like this. So this great circle that is perpendicular to that axis is called the person's horizon. That is known now from the vertical system. So now there's a point that says the celestial axis, the celestial equator, this celestial equator cuts the horizon in 2 points, the east point on his right hand side or the west point. So can you see now what is going to happen? There's this point here where the horizon is going to meet this celestial equator. Can you see that? And there's another point right there at the back where the horizon is meeting the celestial equator right at the back. So there's going to be our east point and our west point. With my drawing here, this is going to be my east point and this is going to be my west point probably, or that is if the person is facing that side. If the person is facing this side, then definitely on his right hand side it will be that side. If the person is facing this side, his right hand side is that side, so the east point will be there and his west point will be here. If the person was facing this side, then his east point will be up out of this page like this on the west side, and then so here this person, we are saying this person is facing this north celestial pole, so the east point is that side and the west point is there. So these are the 2 points that the celestial equator meets the horizon. So now great circles perpendicular to this equator are called hour circles. So you remember in our vertical system we're going to draw circles that pass like this, cutting the horizon and then going to the nadir. That's what we're going to draw. But in this equatorial system, everything is done with respect to the equator. So we are going to draw circles that are perpendicular to this equator. So instead of circles that are like this, we are going to draw great circles that start from the north celestial pole all the way, cutting the celestial equator and then crossing to the south celestial pole and going all the way behind them. So these circles here there's going to be another circle obviously here, just here. There's going to be another circle here like this, and another, all those circles like this that are perpendicular to the plane. Their planes are perpendicular to the plane of the equator. Just like we had the vertical circles, I hope I'm not confusing anyone. We had the vertical circles in the previous system, the vertical system. We had the vertical circles like this, but now we are doing circles that are like this, that are perpendicular to the equator, because we are now doing an equatorial system, and everything now hinges on the on the equator. So these ones here, they are called hour circles. They are called hour circles. On Earth, the ones that are a bit like this, they are called the meridians. In the vertical circle, in the vertical system, they are called the vertical circles. But now here they are called the hour circles. They are called hour circles. So now the horizon circle through the zenith nadir is identical with the vertical circle. The horizon circle through this. Can you see? There's going to be an hour circle that is going to pass through, because when our circles are drawn from the north celestial pole, cutting the equator to the south celestial pole. So there's obviously going to be a vertical circle, an hour circle that passes the north celestial pole, the zenith, cuts the equator, and then comes here, and it connects like that. This is called the observer's celestial meridian, just like we defined it previously. It connects the NCP, the Z, the SCP, and N. That is the celestial meridian. So it's the observer's celestial meridian. It's called the observer. The emphasis on observer is because it cuts through the zenith and the nadir, which are the 2 points. They are specific to what? They're specific to why is Houston saying member? It's supposed to be meridian. The zenith and the nadir are specific to the observer. That's why there's this emphasis of observer celestial meridian, because they differ or depending on what? On the observer. So now that we've defined this, we've defined our celestial meridian. Can you see the celestial meridian cuts the equator at 2 points? The celestial meridian is this outward circle, and this is our celestial equator. It cuts at this point and at this point, isn't it? It cuts them at those 2 points, of which one is going to be above our horizon. Can you see our horizon? One of those points where the celestial meridian, observer celestial meridian, cuts the celestial equator, this one, is above our horizon, because this is our horizon. And can you see it is above our horizon? And the other will be below our horizon. It will always be below our horizon. So one will always be above the one, not like always, but I mean as in one, there will always be 1 point above and 1 point below. So this one is below the horizon, and this one is above the horizon. I hope this diagram is not confusing anyone, but if you follow through the video, I think it makes sense if you follow through this video. So the one that is above the horizon, is chosen as our origin. So our origin is where, in the first equatorial system, our origin is defined as the point where the observer celestial meridian cuts the celestial equator, just like that. So this is going to be our origin. So now that we have defined our origin, we are going to start defining our coordinate system, and I think in the next video, that's where we are going to start defining our coordinates. In this video, we just wanted to introduce the first equatorial system and seeing how we are going to measure the things. In the next video, we are actually going to put angles to it. So stay tuned for that one.